If universal set is a set of lowercase letters from A through J, S is a set consisting of lowercase letters A, E, and I, T the set consisting of lowercase letters A through E, then S, U, T. S, U, T, S union T. Okay, that stands for union. There's some ambiguity between the U here and the U up here, but the U here stands for union, is the set of elements that are in S or in T. Set of the elements of the universal set that are in S or in T. So we can go through the universal set, check each element of the universal set, since there aren't that many of them, and determine whether each of these elements appears in S or in T. A appears in both S and T, so certainly it appears in S or T. So A is in the set. B appears in set, doesn't appear in set S, but it does appear in set T. So it appears in set S or set T. Therefore it goes here. C doesn't appear in S, but it does appear in T, so it's included. D doesn't occur in S, does occur in T, so it's included. E does occur in S, so it's included automatically. It also occurs in T, but that doesn't make any difference. And then the only other element in either of these sets that hasn't been considered is I, and that's going to be included. And if we went through all the elements of U, when we came to I, we would draw the conclusion that I goes here. Somebody in class characterized this as just saying you combine the two sets. That's really what you're doing. But you also want to know the definition. If it's in this set, it's in here. If it's in this set, it's in here. Okay, set S intersection T. Intersection means it's got to be in both sets to be in the intersection. So we don't even have to look at the set U. We just look at the sets S and T, and we say, okay, let's see. A is in S, it's also in T, so it's in the intersection. Okay, well, E is the next element in set S, and since any element down here has to be in both sets, we don't have to consider B, C, or D. We just consider E, and we find that E is also in T, so it's going to go here. And then I is the only set element left in the set S, and it does not occur in T, so it's not going to be in the intersection. So the intersection is going to consist just of A and E. Now the complement, S union T prime, that possibly is read as a prime, or S union T with a bar over it, both mean the same thing, mean the complement. That means every element of this set, every element of the universal set that is not in this set. Okay, so the elements of this set will not be included, but everything else in the universe will be included. Well, A is in S union T, as is B, C, D, and E. So A, B, C, D, and E will not be in the complement because they are in the set. The next element after E that's in the universe is F, which will be in the set, then G, which will be in the complement of this set because it's not in this set. H will be in the complement because it's not here. I is here, so it's not going to be in the complement. And the only remaining element of the universal set is J. It's not here, so it appears in the complement. So if we put this set has nothing in it that this set does. And if you put these two sets together, you get the universal set. Similarly, S intersection T prime or S intersection T bar is going to consist of everything in the universe that's not in S intersection T, which means it's going to be everything here except for A and E. So it won't have A, but then it's going to have B, C, and D. It won't have E, but then it's going to have F, G, H, I, and J. So there is the complement of the intersection of our two sets.